Question number 4 from section 3.4 asks us to describe the end behavior of the graph of the polynomial function. When you're looking at these, you really only need to look at the leading term. The leading term is 8x to the 5th. Now, because the leading term has a positive leading coefficient and it has a odd exponent, odd power exponent, then you can actually make your decision based on those two things. If it's a positive leading coefficient, that means the graph is going to end up on a high note. Think about being happy. It's positive. It's going to end up on a high note, going up towards positive infinity on the right side of the graph. Also, because it has an odd power, it's going to go in the opposite direction on the left-hand side of the graph. So this end behavior is going to go towards negative infinity as you go to negative infinity, and it's going to go to positive infinity on the right hand of the graph. Positive leading coefficient always ends up positive. The odd exponent means that it goes in the opposite direction. So make your decision based on that leading term. All right, let's look at number 5. Again, you're just making your decision based on the leading coefficient. The leading coefficient is, leading term is negative 6x to the 3rd. It is a negative leading coefficient. Okay, and what that means is it's going to end up on a low going down the graph. Think of a frown, it's negative, it's not happy, going towards the right side, right half of the graph. This has an odd exponent, odd leading power, or we even call that the degree, the odd degree of the polynomial. That means it's going to go in the opposite direction. If it's negative leading coefficient, it's going to end up going towards negative infinity on the right half of the graph. Because it's an odd degree, odd power, then we can say it's going to do the opposite on the other side. So on the left hand of the graph is going to go up the page. On the right hand of the graph, it's going to go down the page. Okay, let's look at number 6. Looking just at the leading coefficient, you can make your decision about what the end behavior looks like for the graph. The leading term is 2x to the 6th. Positive leading coefficient. Okay, what that means is it's going to end up on a happy note. It's going to go to positive infinity on the right hand of the graph. Because the degree of the exponent, the exponent is even number for the exponent, or even degree, the degree of the polynomial is the greatest exponent. It's going to do the same on the left half as it does on the right half. On the right half, it goes towards positive infinity. On the left half, it's also going to go towards positive infinity. If the polynomial is even, has an even degree, the largest exponent is an even number, the right half direction is the same as the left half direction. You can check your answer. Okay, here's another one, question number 7. You want to look at the leading coefficient, but be careful here. It's not written in our traditional format. The leading coefficient, or leading term, is really negative 8x to the 10th. The leading term is always the term that has the greatest exponent. Because this is negative, that means the graph is going to end on going towards negative infinity on the right half of the graph. Because the exponent is even, then whatever happens on the right half, it's going to do the same thing on the left half. So the leading coefficient is negative, it's going to go towards negative infinity on the right half of the graph. The exponent is an even number, so it's going to do the same thing on the left as it's going to do on the right. Okay, so as you can see, based on those last few, you can do these fairly quickly if you know the rules. Look at the leading coefficient. It's always the term with the greatest exponent. If it's positive, it's going to end up going towards positive infinity. If it's negative, it's going to end up going towards negative infinity. The power tells you if it's going to do the same or opposite. If it's an odd power, it does the opposite. If it's an even power, it's going to do the same.